This is a Calc 2, Spring 23 final. I just woke up, so might make a lot of mistakes, but hopefully I won't. Compute the following integral. This is a pretty basic, what's it called, integration by parts, LIATE. Whatever comes first will be our u. U is equal to, do we see a log? No. Do we see inverse trig? No. Algebra? Yes. X squared. So our du will be equal to 2x dx. So our dv will be equal to what's left over, which is sine x. So v will be equal to derivative, or antiderivative of sine is going to be negative cosine x. Applying our integration by parts formula, we're going to get negative x squared cosine x minus the integral of, actually a negative will become a positive. So it'll be a plus the integral of cosine. It will be a, and since this is a 2, we can bring that on front because it's a constant. X cosine x dx. We see here this requires another integration by parts, LIATE. U will be equal to x here, du will be equal to dx, so dv will be equal to cosine x dx, and v will be equal to sine x. Negative x squared cosine x plus 2 parentheses. Applying our integration by parts formula, we're going to get x sine x minus integral of sine x dx. Sine x dx. This is going to be equal to negative x squared cosine x minus 2. Just put parentheses x sine x minus antiderivative of sine is going to be negative cosine, so it's going to be positive cosine x plus c. And this should be right. You can distribute the 2 in, but I don't think you have to. I don't really see why you would have to. So this should be right. Okay, part B. How do you do this? Oh, this is a pretty basic, what's it called? Partial fraction decomp. So if you have 1 over t squared, t minus 1, this will be equal to a over t plus b over t squared plus c over t minus 1. If we multiply everything here by t squared times t minus 1, what you're going to get is 1 equals a times t and t will cancel, leaving us with the t times t minus 1, which is going to be t squared minus t squared minus t, plus b, oh wait, this is a t squared, my bad, yeah, t squared, so this will give us t minus 1, plus c, this will just be a t squared. So from here, if we set, say, t is equal to 0, here, this is going to be 0, this is going to be 0, and this will be a negative 1. So we're going to have 1 is equal to negative b, so our b will be equal to negative 1. And what else can we set t is equal to? If we set t is equal to 1, this will be 0, so that would work. And this would be 0, so yep, that would work. If t is equal to 1, we're going to get 1 is equal to 1c, so c is equal to 1. Now if we set t is equal to, we tried 1, we tried 0. Can we do let's try 2 then, okay? If we do 2, it's going to be 1 is equal to, so it's going to be a 4 minus 2, which is going to be a 2. So it's going to be 2a plus b. 2 minus 1 here is going to be 1, so it's going to be b, which is negative 1. So plus negative 1 plus c, substituting in 2 for t is going to be 4. 4 times 1 is going to be 1 plus 4. This will give us negative 4 plus 1 is going to be it's going to be positive 3. Subtract it on the other side, you're going to get 2. You're going to get negative 2. So you're going to get negative 2 is equal to 2a. So a is equal to negative 1. So from this, we can apply like the partial fraction decomp. We plug it into the integral from 2 to 4 of negative 1 over, what is it? Negative 1 over t plus negative 1 over t squared plus c, which is 1 over t minus 1 dt. And this becomes a pretty basic, yeah. So this would be negative ln absolute value of t plus, so here, this is going to be actually a minus. This is going to be a, we should rewrite this as minus t to the negative 2. T to the negative 2 is going to be t to the negative 3 divided by negative 3. So in fact, this will actually be a positive. And is this right? I think I did this right? Oh wait, no. For a, okay, that's why I was looking a little weird. For integration, we add by 1. So this is negative 2. So it'd be a plus t to the negative 1. Because you added by 1 and subtract. Okay, that's right. Yep. Plus, this is going to be ln of absolute value of t minus 1 from 2 to 4. This is going to be equal to negative ln 4 plus, what is this? It's 1 over t, so it's going to be 1 over 4 plus 1 over 4 plus ln of 3. This minus a negative ln 2 plus 1 over 2 plus ln of 1, which is 0, but we don't care about that. And that should be our answer. Decide whether the following integral converges or diverges. We do not need to compute its value if it converges. Okay, so this right here is a pretty basic comparison test, it seems. So if we do 14 divided by x to the 5th power plus 49, if we said this is a of n, this would be less than, actually if we compare it to this, x to the 5th power, this will always be greater. We can say all terms are positive. I can't spell, but yeah, there we go. If we compare to this, and we can say this is equal to 14 divided by x to the 5 divided by 2, which is x to the 2.5. And if we say, so since the integral from 1 to infinity of 14 divided by x to 2.5 dx, this will converge by p-test, where p is equal to 2.5, which is greater than 1. Therefore, integral 1 to infinity of 14 divided by x to the 5th power plus 49 dx will also converge by comparison test. Theorem. Find the general solution of this. So here, this is a pretty basic linear differential equation thing, where integrating factor is just negative 4. Okay, so that's, yeah, this seems pretty easy, I think. Yeah, okay. So integrating factor is mu is going to be equal to e negative 4 dx. This will be equal to e to the negative 4x, which will be equal to 1 over e to the 4x, and multiplying everything by mu minus 4 mu y is equal to 3e to the 2x times mu. Now, if we do like the reverse implicit differential equation thing, what you're going to have is mu times y will be equal to 3e to the 2x times mu. Integrating both sides of this, on the left side, by some like fundamental theorem of calculus or something, I don't know, a long time ago I learned it. Basically, an integral of a derivative, it's just what's on the inside, so it's going to be mu times y. And mu, we said it was, so it's going to be y over e to the 4x is equal to, this side, the right side is going to be 3e to the 2x divided by e to the 4x dx. This is simply equal to 3 integral of 1 over e to the 2x dx. So we can also rewrite this as like e to the negative 2x. So we rewrite this as this. We're going to get 3 integral of e to the negative 2x dx. This will be equal to 3 divided by 2 will be a negative 3 divided by 2e to the negative 2x plus c, I believe. Do we have a... No, we don't. Does it want us to solve for y? I don't know, but let's just solve for y because it's not that hard anyways. So y will be equal to negative 3 over 2 e to the negative 2x plus c. Take all this, multiply by e to the 4x. And that should be your answer. Find the solution to following initial value. Okay, so we got an initial value. So we just had a linear, so we're going to have a separable, obviously. And here we do have a separable. So this seems a little bit more complicated. We have all x's right here, all y's right here. Group them all together. We can divide the y over. We're going to get 1 over y squared, which is equal to 1 over y squared. To make this easier to integrate, let's just write y to the negative 2 dy will be equal to secant to the third power x and then tangent x dx. Integrating both sides, the left side is pretty easy to integrate. The left side will be y to the negative 1 divided by 1, so it's going to be negative 1 over y. Negative 1 over y will be equal to, the right side is a little bit more complicated. We can manipulate this a little bit by doing, by applying our knowledge of Pythagorean identity. Sine squared plus cosine squared is equal to 1. And if we divide everything here by cosine squared, what you'll end up with is sine divided by cosine, which is tangent. Actually, do we want to do that? I don't think we want to do that. I don't think we need to go that far, actually. Wait, let me think. Yeah, actually, we don't need to do this. I was thinking this too complicated. I think that would work too. But here, if we just set u, so for example, if we set u is equal to secant, right? Our du would be equal to derivative of secant is secant tangent dx, x here, right? So therefore, a secant will cancel out and a tangent will cancel out. So now we have the integral of one secant will cancel out, leaving us with the secant squared. So secant squared u, and the tangent will be canceled out, so du. Okay, this makes it a lot more easier. So negative 1 over y will be equal to derivative, or antiderivative of secant squared is going to be tangent u du. And remember, we're in u now. We need to put this back into x. So tangent u replace that with what it is secant x plus c. And I think I did this completely wrong because I'm stupid, but actually, yeah. Secant x is this. I forgot to replace u with what it is. This is going to be secant squared, so it's going to be u squared du. The integral of this is going to be u to the third power divided by 3 plus c, 1 over what? Now replacing u with what it is, which is secant. Secant to the third power x divided by 3 plus c. 1 over this. This will be your answer. Or actually, this will be our not answer yet. It will be our answer soon. So when x is equal to 0, y is equal to 2. So negative 1/2 is going to be equal to 0. What is secant? Secant is 1 over cosine. So cosine of x, if cosine of x is equal to 0, so looking at our unit circle, if cosine of x is equal to 0, at 0, what is our y? Y is going to be, the x value at 0. The x value at 0 is going to be 1. So 1 divided by 1 is still 1. So you're going to get 1/3 plus c. So therefore, in this case, c will be equal to -1/2 minus 1/3. So now we can rewrite this back into our equation. Secant 3x divided by 3 minus 1, replacing c with what it is, which is this. And that should be our answer. But if we want to solve for y, we can. Solving for y, we would get 1 over negative secant cubed divided by 3 minus 1/2 minus 1/3 will be equal to y. I think either one of these would be correct. Okay, determine whether the series is divergent, conditionally convergent, or absolutely convergent. Okay, so we have to realize if we take the... Okay, so basically sine is bounded between... Basically this is bounded between... The biggest it can be is 1. The smallest this can be is -1. Take the absolute value, we can ignore this here. Looking at all positive terms, all term positive. Looking at all the positive terms, we can just look at this part right here. Based on this, we can use a direct comparison here. If we say sine of 2n to the 3rd power plus 3, all divided by n to the 4th power plus 8, this will be less than or equal to, replacing this part with 1, we're going to get 4 on top, divided by n to the 4th power plus 8 to the 4th power plus 8. We can say this is equal to, actually wait. Yeah, we can also keep going with this, 2 being over n to the 4th power. And this is equal to 4 over n squared. If we say this is equal to a of n, and this is equal to b of n, we can say a of n and b of n are positive. We have to state this to do a direct comparison. Now we can compare simply this. So we know the bigger term will converge. The summation as n equals 0, n equals 2 I guess, n equals 2 of 4 over n squared will converge by comparison test. Actually, it will converge by p-test, or p-series, where p is equal to 2, which is greater than 1. So therefore, sine of 2n to the 3rd power plus 3, all divided by root of n to the 4 plus 8, will converge by direct comparison. And since all term positive, will converge absolutely. Okay. Determine the radius of convergence of the series. So this is a very basic one that you should be really fast at. You just do a ratio test. So basically, the limit as n goes to infinity of the absolute value of a of n plus 1 of a of n will be equal to the limit as n goes to infinity of 3n plus 1 x plus 1 to the n plus 1 all over n plus 1 squared. This is the 1, sorry, times n squared divided by 3n x plus 1 to the n power. This will be equal to the limit as n goes to infinity. This 3n and this 3n will cancel, leaving us with the 3 on top. The absolute value of 3 on top. And then this and this will cancel, leaving us with the x plus 1 on top. And then this and this does not cancel, therefore we'll just leave this as it is, n plus 1 squared. We can rewrite this as the limit, actually no. We can rewrite this by bringing the constants out in front. 3 absolute value of x plus 1. The limit as n goes to infinity of n squared divided by n plus 1 squared. Now, this will be equal to 3, leaving the constant alone. just worrying about the limit for now. The limit as n goes to infinity. Multiplying the top and bottom by 1 over n squared, we're going to get 1 over 1 plus 1 divided by n squared. This right here will give us, this will go to 0. So we're going to get 1 over 1. So this term right here will be 1 over 1 squared. So this will just leave us with 3 plus 1, absolute value of x plus 1. And we need this less than 1 for it to converge by ratio test. So if this is less than 1, we can conclude that x plus 1, when the absolute value x plus 1 is less than 3, this will converge. Therefore, the radius of convergence will be equal to 3. Now it wants us to determine the interval convergence. The interval convergence, we can look at this right here and plug in the endpoints to see if it's convergent or divergent. So we have absolute value, which is a piecewise function. So we're going to have x plus 1 is less than 3, which will give us x is less than 2. And we also have a negative x minus 1, which is less than 3. So this will give us what? Negative x is less than 4. And then multiplying negative 1 on both sides, or dividing negative 1 on both sides, we're going to get x is greater than negative 4. So basically, so far, we have negative 4 is less than x, which is less than 2. We need to test negative 4 and 2 at the endpoints to see if they're convergent or divergent. Let's test 2 first. When x is equal to 2, plugging in here, we're going to get what? N equals 2, or n equals 1, sorry. And we're going to get 3n. And then x plus 1, which is 2 plus 1, which is 3n, divided by n squared. This will be equal to equals 1. This and this. Wait a second. This seems weird. Did I do something wrong? I must have did something wrong because they should not be like this. I'm stupid. Okay. Basically, here, the radius of convergence is equal to 1 over 3. Sorry, because you take this and divide it over. So this justification is all wrong. This is all wrong. So we need to redo this. Okay, so this will yield x is less than 1/3 minus 1, which is going to be what? Negative 2/3, I think. And this will be x is less than plus 1 is going to be what? 4 over 3. 4 over 3 negative. So dividing negative 1 on both sides, we're going to get x is greater than negative 4 over 3. So this will yield 4 over 3 is less than x, which is less than negative 2 over 3. Okay, that seems more right. So plugging this in, we're going to have x plus 1, okay? When x is equal to, let's test negative 4 over 3 first. Negative 4 over 3. When x is equal to negative 4 over 3 plus 1, you're going to get a negative 1 over 3 to n. This will give you a negative 1 to the n divided by n squared. And this will, we know this will converge by alternating series test. So converge by alternating series test. Alternating series test. But for alternating series test, you must state 4 things. B of n is equal to 1 over n squared. This is positive. Positive. Decreasing because denominator is increasing. So that's 1, 2, and then the third thing would be it's continuous. And the limit as n goes to infinity of 1 over n squared will be equal to 0. So if all 4 of these conditions are met, which they are, this will converge by alternating series test. So when x is equal to the other value, which is negative 2 over 3, negative 2 over 3, you're going to have the summation n equals 1 of 3 to the n, and then 1 plus this, which will give you a 1/3 to the n, divided by n squared, will be equal to the summation of n equals 1. We can see here, this will just be 1 over n squared. we know this will converge by p series. P series where p is equal to 2, which is greater than 1. So at both of these endpoints, they converge. So we can write square brackets. Square brackets, -4 divided by 3, comma, -2 divided by 3. This is our interval convergence of convergence. Find a power series representation for this. Okay, so from our formula sheet, if you don't have it memorized, you can just look at the formula sheet, but basically, inverse tan of x will be equal to summation n equals 0, -1 to the n power times x to the n 2n plus 1, I think, over 2n minus 1. No, it's 2n plus 1. Yeah, that should be right. Okay, based on this, if we plug in the first, when we plug in n equals 0, -1 to the 0 power is going to be 1, so we don't have to worry about that. And then this is going to be, what, 2? Actually, no, it's going to be 1. Actually, no, it's going to be x. That's right, yeah. Because 0 times 2 is 0 plus 1 is 1. X to the first power is just x, divided by 1, which is still x. Now plug in n equals 1. We're going to see that -1 to the first power is negative, so I wrote a negative sign. And then 1 times 2 is going to be 2 plus 1 is going to be 3. So x to the third power divided by 3. Plus, if we plug in 2, we're going to get a positive. -1 squared is going to be positive 1. And then it'll be 2 times 2, which is 4, plus 1 is going to be 5. X to the fifth power divided by 5. Minus x to the, now we're plugging in 3. It'll be 2 times 3, which is 6, plus 1, which is 7. Divided by 7. Plus dot 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 and so on, right? So, in this case, we have x, we have arctan of x squared. So every single x we see, let's replace that by x squared. So the first one is x squared minus x squared to the third power divided by 3 plus x squared to the fifth power divided by 5 minus x squared to the seventh power divided by 7 plus dot 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 and so on. So we also have an x in front of arctan. So x of arctan of x squared will be equal to, let's multiply every single x we see here by another x. So it's going to be x to the third power. And then we're going to have x 2 times 3, which is going to be 6. So it's going to be a minus x to the 7 divided by 3 plus this to the 10 plus 1, which is going to be 11. So x to the 11 over 5 minus dot 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 dot. Don't want to calculate it anymore. So basically, based on this, we can conclude that x inverse tangent of x squared will be equal to summation equals 0 of -1 to n times an x, and then every single, this x comes from here, and then the x under all the power is going to be x squared. X squared to the 2n plus 1 all over 2n plus 1. Simplifying this a little bit more, we're going to end up with two times 2 is going to be 4, so we're going to have x to the 4n plus, it's going to be plus 3, but if you're going to have a plus 2 plus another x, it's going to be plus 3, all divided by 2n plus 1. And this is your answer. Use the 8th degree polynomial centered at 0 to approximate the value. This is the series that's like, it starts with an M. I don't know how to say it, but yeah. So, we know that e to the x is going to be equal to the summation n equals 0 of x to the n divided by n factorial. Looking at this, we know if we plug in like 0, we're going to get what? We're going to get 1, I think. Yeah, you're going to get 1. Plus, if you're going to plug in 1, you're going to get x divided by 1, which is just x. Then you're going to get plus x squared divided by 2's factorial, which is 2, plus x to the third power divided by third factorial, plus dot 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 and so on. So e to the x to the fourth power, let's replace every x we see here with the x to the fourth power. So we're going to get 1 plus x to the fourth power plus x to the fourth power squared divided by 2. And notice it says 8th degree Taylor polynomial. So we only need to go to the 8th degree Taylor polynomial. So t f of x is going to be equal to, which is just here, so we don't need to continue. So this is going to be equal to 1 plus x to the 4 plus x to the 8 divided by 2. So therefore we can say that the integral of negative 1/2 to 1/2 of e to the x to the fourth power dx will roughly be equal to the integral of negative 1/2 to 1/2 of 1 plus x to the fourth power plus x to the 8th power divided by 2 dx. This will be roughly be equal to, integrating this, we're going to get x plus x to the 5th power divided by 5 plus x to the 9th power divided by 18. Evaluating this from negative 1/2 to 1/2, we're going to end up with 1/2 plus 1/2 to the 5th power divided by 5 plus 1/2 to the 9th power divided by 18. All of this subtracted by negative 1/2 plus negative 1/2 to the 5th power divided by 5 plus negative 1/2 to the 9th power divided by 18. And this should be your answer. Find the Taylor series centered at 1 of f of x equals this. Okay, so to do this, we need to write it out in this form. F of x will be equal to 2 divided by x, which is also known as 2 to the negative 2 times x to the negative 1. F prime of x will be equal to negative 2x to the negative 2. F double prime of x will be equal to a positive 4x to the negative 3. F triple prime of x will be equal to negative 12x to the negative 4. Now f of 1, because centered at 1, this is going to give you a 2. F prime of 1 will give you negative 2. F double prime of 1 will give you a 4. F triple prime of 1 will give you a negative 12. We see this is positive and negative, positive, negative. So we know there's going to be a negative 1 to the n power somewhere. So in general, we can say f of 1, f of n of 1 will be equal to negative 1 to the n power because it's alternating back and forth, right? And we see a 2 go to a 2, go to a 4, go to a 12. So we know there's going to be a factorial in here somewhere because it's a 2 to a 2 still. And we know like 0, and if we do n factorial, 0 of this is going to be 1. 1 of this is also going to be 1. That's why this is constant, staying at 2. So we're going to have a n factorial in here, and we're going to have a 2. So, but this makes sense. Let's try this. So if we plug in 1 here, we're going to get, actually if we plug in 0 here, what are we going to get? If we plug in 0, we're going to get 2, which is correct. If we plug in 1, we're going to get negative 2, which is correct. If we plug in 2, we're going to get 2 factorial, which is 2 times 2 is 4, and this will be a positive, which is 4. That's correct. If we plug in 3, we're going to get negative 12. So far this is right. So the Taylor series centered at x equals 1, the formula for Taylor series, n equals 0, is going to be f of n of 1 divided by n factorial x minus a to the n power. So plugging in what we have so far, we're going to get n equals 0. And then replacing this with this, we're going to get negative 1 to the n power 2 times n factorial divided by n factorial x minus a is the center, which is 1. We can see this simplifies. 0 of negative 1 to the n power, and this would be a 2 times the 2 times x minus 1 to the n power. And that should be our answer. Use Taylor series to answer these questions. You will not receive credit if you do not use Taylor series. Compute the sum of this. So we need to look for something that looks like this. What is something that looks like this? Recall that e to the x will be equal to summation of n equals 0 to infinity of x to the n divided by n factorial. So we can see this is equal to ex, right? So here, in this case, x is equal to ln 2. So we can simply just replace e to the x with e to the ln 2. And this is equal to 2. So our answer is just equal to 2. And that's pretty simple. Compute the limit as x goes to 0 of this. So recall that cosine x is equal to the summation as n equals 0 to infinity of negative 1 to the n, and then x to 2n divided by 2n factorial, like this. So the limit as x goes to 0 will be equal to of 1 minus 1 half x squared minus, now let's expand this out a little bit. Expanding this out a little bit, if we plug in 0, we're going to get negative 1 to the 0 power, which is 1. X to anything is going to be, so we're going to have 1 at first, plus, actually be a minus actually. Would that be a minus? If you plug in 1, you're going to get negative 1 to the first power, which is negative 1. So yes, it will be a negative. And then x squared divided by 1 times 2 is going to be 2, so it's going to be 2 factorial, which is just going to be 2. We can already see this one and this one will cancel, and this will cancel. So we need to go on to do one more term. The n equals 2 term. When n is equal to 2, we're going to have positive 1 times x to the 4th power divided by 4 factorial. And plus dot 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 and so on. All this is being divided by x to the 4th power. So the limit as x goes to 0 of this will simply simplify down to x to the 4th power divided by 4 factorial plus dot 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 so on, all divided by x to the 4th power divided by 1. And this will simply be equal to the limit as x goes to 0 of 1 over 4 factorial, which will just be equal to 1 over 4 factorial. And this will be our answer. Find the vector projection of this onto this. So we say this is B and this is A. So the vector projection of B onto A will be this formula. It will be A dot B over magnitude of A squared times A. So A dot B will be equal to 2 times negative 1 plus 4 times 3 plus 5 times 1. 5 times 1, which is going to equal to 5. Which this will be equal to negative 2 plus 12 plus 5, which will be equal to 15. And let's find the magnitude of A squared. This will be equal to, what is A? A is negative 1 squared plus 3 squared plus 5 squared. This will be simply equal to square root being squared will just be whatever it's on the inside. So you're going to have 1 plus 9 plus 25, which will give you 35. So this will be, so the vector projection of B onto A will be equal to 15 divided by 35 times A. A is -1, 3, 5. So we can see here, this will be equal to -15 divided by 35, comma, 3 times 15 divided by 35, comma, 5 times 15 divided by 35. And this should be your answer. Find the equation of the sphere with the center that contains the point. Okay, so the center we're given here. Let's just write that out so far. So x minus 1 squared plus y minus 0, so it's just going to be y squared, plus a z minus 2 squared will be equal to the radius squared. So what is our radius? That's the only thing that's, like, we don't know. We need to solve for that. So the radius will be basically be the distance from the center to the point on the circle, or on the sphere, right? And how do we find that? So radius will be equal to the abs, or square root of one point minus another point. Square root of 1 point minus the other point squared. So basically it'll be, let's take this as A and this is B. So it'll be A1 minus A2. Actually it'll be A1 minus, if this is A and this is B, it'll be A1 minus B1 squared. So 1 minus -2 is going to be a 3. This will be 3 squared, plus 0 minus 1, which is going to be -1 squared, which is going to be 1 squared, which is going to be 1, plus 2 minus 1, which is 1, so it's going to be 1 squared, which is going to be this. R will be equal to square root of 9 plus 1 plus 1, which will be equal to square root of 11. So this is R, and we replace R with where it is here. We're going to get 11, square root of 11 squared, which is just 11. And that's just our equation of the sphere. It's pretty simple. Find the equation of the plane through the point and perpendicular to the given line. Okay, so the direction of the line is going to be 1, -4, and 5. The plane is going through this point. And since it's perpendicular, we know the dot product is going to be 0. And the plane is going to be through this point with the normal being this. So therefore, we can just, I guess we can just write the equation of the line, right? Since this is the point, it'll be x minus x, which will be x plus 1. And then -4 here, -4, y minus -3, which is going to be y plus 3. And then plus 5 z minus 7 will be equal to 0. And that should just be your answer. Find the parametric equation of the line that contains the point. It's perpendicular to given line and perpendicular to a vector. So we're given two vectors, perpendicular to this vector and perpendicular to this, and a point. So to write an equation of a line, we need two things. We need a point and a direction. To find a direction, we can do a cross product of two vectors. So if we set this is equal to, say, u. So u is equal to 3, -2, 0. And we set w is equal to the other one, which is what? 1, -4, 5. 1, -4, 5. And we do w cross u. This will simply give us a matrices of I, J, k. And we'll have a 1, -4, 5, and a 3, -2, 0. I'm gonna move this down a little bit because it's too cramped. There we go. Doing the little trick stuff, you're gonna get this, and then you're gonna get -4, 5, -2, 0, minus, because you use alternate signs, you're gonna get 1, 5, 3, 0, plus k, and you get 1, -4, and then 3, -2. This will be equal to I. Okay, so -4 times 0 is going to be 0, and then minus 2 times 5, -2 times 5, which is going to be a positive 10, minus a j. 1 times 0 is going to be 0, 3 times 5 is going to be a -15, plus k. 1 times -2 is going to be -2 minus a positive, minus a negative is going to be a positive, 12. This is going to be equal to 10. What is that? Ooh, that's going to be a 15. And then -2 plus 12 is going to be 10. So we want the, what is it, the parametric equation? So x will be equal to the point, -1, -3, -1, -3, 7. This is our point. So we're going to start with the point plus 10t. Y is equal to -3 plus 15t. And z will be equal to 7 plus 10t. And this is our set of parametric equations that satisfy this condition. And that's it. We're done.